installation in progress at Chennai, Kolkata, and Mumbai, and definitely up next week onward, it Goa also will be on the same line of installations. Once again, I welcome all of you in this short flash course on mini IPMS startup. First, we will just introduce the mini IPMSs. We will talk about the overview of IPMSs, its advantage, its architecture, etc. IPMSs basically it stand for AMSs. That means automatic message switching system over IP-based communications. That is called IPMSs. Mini IPMS is nothing but it is almost equivalent to IPMSs, and it is formerly known as a AFTN message switching system. And definitely nowadays any system is a computer-based system, but this system is mainly concerned on the AFTN subject and responsible for exchange of AFTN messages, which is formerly known as the aeronautical message, by means of auto switching for distribution of messages to its destinations. And it will work on a message switching principle. Message switching principle says that we will store the information first, then we will forward the information. That is known as a store and forward principle. That is the basic concept of message switching. If we just divide the complete area to major part, then we have a 4 major area in the AMSS systems. That is the mini IPMSS systems or normal AMSS or IPMSS. First part is a system. Definitely there should be a system. System means some computer in a network. In mini IPMSS is a dual architecture computer based system consists of few machines. This machine may be a normal laptop, it may be a desktop PC, it may be a server or a workstation, whichever may be, or a link with each other over a local area network, and subsequently connected with other AMSs or other system through BSNL, MTNL, satellite, other media to form a wide area network. When we say the dual architecture computer based system, that time we want to mean that in the main system there will be two machines which will act as a dual architecture. That means one system will be in online system, another system will be hot standby. In case of shutdown of the one system, other system will take over the charge automatically. That is known as a dual architecture. Then this system is basically for AFTN message. So message play a vital role in the IPMSS system. This mini IPMSS is responsible mainly for exchange of AFTN messages as defined by ICAO. But at the same time, it can handle some non-AFTN messages within this local network. When we say AFTN message and non-AFTN message, you have to keep in your mind that when we say AFTN message means the messages which you are familiar to see, starting with the ZCSC, ending with the NNN, that is ICAO ITA2 format, or maybe starting with the startup heading, ending with the end of text in ITA IFI format. And non-AFTN message is a specialized message used by the system for its own management, not following the ICAO format, that is known as a non-AFTN messages. Just for example, suppose you are handling supervisor's workstation, you give a command to change over one route to another route, that is formally known as a route diversion. That also a message, and that message also dealt by the mini IPMSS server. So you have a two type of messages. So one is a AFTN messages, another is a non-AFTN messages. When we have the system and we have the message, definitely we have a next function is switching function. Many IPMSs receive messages from user terminal connected to it directly, or also from terminals or lines or system connected indirectly via other switch, router, media, etc. After receiving the message, it analyzes the message, stores the message, and then automatically retransmit the message to its destination. During the above process, it uses switching system, which allow on demand basis the connection of any combination of source and sink. That means, suppose your message is carrying some address, will go to from Goa to Bombay, and message will go at the same time from from Goa to Tower Terminal, say. So, reading the address, it will switch the message on demand basis. That means on demand, what is the demand? I have to make a connection with the Bombay. At the same time, I have to build one connection with the tower. Here source is Goa and sink is Bombay and tower. So accordingly, it will establish the link. If the link is already established, it will transmit the messages accordingly. No system is 100% complete unless the application software is there. Many AMSs use mainly three type of application softwares. Message switching application, which is a main application for switching the messages, and that will be in the main server. Then some IP-based communication process and applications that also will be in the main server, and some customized user content applications that will be your you will be used in the worksheet. Definitely that new AMSs has lot of advantage compared to the previous ECL system. First of all, this system is more flexible on hardware and software with COTS product and ready to support present days any machine as well as future platform. You can establish your IPMSS system even with the help of laptop, with the help of machine or workstation or server type of machine you are using. So it is more flexible. Since this software is designed on the Linux platform for the switching, as you know, Linux is more flexible, and even on the front-end application is ready to work on the latest Windows platform, whether it is 32-bit software or 64-bit software. You have seen in the ECL system, there was a online server, there was a standby server, then there was a daisy chain to share the hard disk for common storage. This system also a hot standby, cold standby dual architecture, but its common storage concept is completely different, and we have used here a DRBT concept, which will be discussed later on. Now we can communicate with between the AMSs and other network system over the IP and ITA2 and IFI format, which was not available in the ECL AMSs. We can also have a RS-232 communication support to pin server on applications or over the IP serial devices. But always we discourage to use RS-232 communications because simply it is a, when you are using dot printers type circuit, then it is a wastage of papers. There is a unique IP identity for the online server in the dual architectures. And this is a completely new idea introduced in the IPMSs. We'll discuss on this subject later on, and this help a lot for the remote network connectivity, because remote station doesn't know which server is online, and this unique IP identity helps the remote station to continue the connectivity without knowing which server is working at the station. Switching application is designed on the Linux platform, which is ready to run on 32-bit, 64-bit. Also, LP64. Just go to the Google to know what is all this thing. This is the future generations machine which is going to come up, but are already in the market. This software is ready to work on that platform also. This system is compatible with automation system, whether it is a Indra or Raytheon, whether it is a DATIS, whether it is a AOCC, whether it is a D1MET, whether MSS to MSS. Any kind of system is now supported and compatible with the IPMSS. Mini MSS has the limitation, it can support maximum 30 lines. As you know that in ECL system, the limitation was 50 lines. But in mini MSS, we have introduced the 30 lines, and for the metro station, other station, it is 252 lines. Circuit and line speed start from the 300 to unlimited. There is no limitation of 9600 bps. Mini MSS message speed is little bit slow compared to the metro stations. It is 300 to 500 messages per hour. FTN message handling capacity is 50,000 messages per day with storage of 30 days. In old ECL system, it was 50,000 messages per day for the metro stations. In this system are not using any printer but storing the activity logger information in files. This way also we are saving the papers and trying to maintain the green environment in the world. This system has the provision for the time synchronization to time servers or pulling the timestamp from any system which is having the time. Metro. All the application is ready to work on 32-bit or 64-bit platform. It has the provision of remote terminal at remote station, which is formerly known as the RWS applications. Now we have the provision to extend this connectivity to any station, any place, just like a mobile station over the VPN. And now this is becoming more popular in India to cover up the Udan project stations. But there is one restriction, that VPN connectivity. In that case, you have to use the static IP based broadband for internet connections. So we can assume that mini MSS is ready with enhanced facility to overcome present challenges of MSS and to handle future data requirement at non-metro station with lines and message capacity limitations. Now let us go for the system architectures, a general idea how it is connected, how it is working. Now say we have a two machines. Let me say one machine as a server 1 or MSS 1 and another machine as a server 2 or MSS 2. This machine may be HP or Dell machine, or it may be server machine, or it may be desktop machine. But this will act as a mini IPMSS switching server, server 1 and server 2. So our basic first requirement, there should be two machine, computer machine. Now second requirement is that each and every machine should have two SATA disks. or minimum with minimum 2 to 3 LAN card. If you have a 2 LAN card, then also it is manageable. If you have a 3 LAN card, very well manageable. If you have a single card, then also it is manageable. But we prefer there should be 2 to 3 LAN card. Now let us do machine server 1 and server 2. Now every system is having the second SATA disk and individual system second disk of each machine. Now onward we will say that disk name as a DR1 and DR2. DR1 means the second disk of the machine 1 and DR2 means second disk of the machine 2. And DR we have used with the idea that this is a replicated disk. Disk replication will be carried out on this disk. These two disks is logically connected over direct Ethernet connectivity, say ETH2 between the two machines. That means so far we have discussed we have a two machine and every machine is having two hard disks. Second hard disk of the each machine are logically connected with each other over a Ethernet connections between the two machines. And this second disk will use as a storage disk to store the AFTN messages and information. These two disks are replicated with each other through one software formerly known as a DRBD. We will discuss on this subject in our future session. These DR1 and DR2 are physically two different disks of the system, but logically act as a single disk. In initial system, you have seen that disk 0 what was used for a disk. Similarly, here D0 means one logical disk, but physically there is a two disks. Out of these two disks, only one disk will act as a D0. That decision will be taken by the software of the system. Since we are having two Ethernet cards, right now we have told, so another Ethernet card is configured in both the machine for local area network. On this network, your booking, supervisors, etc. will be connected. Health status of both the server is monitored and communicated through a heartbeat software module over the LAN. Whenever it is a dual architecture, there should be a software who will monitor the health of each machine and will communicate with each other. That particular software is known as a heartbeat software. Heartbeat is a new word. This is a very old word, but this software is very costly, in the figure of few lakhs in the market available. But this software is our own design software, doing the same work what the market software is doing. In case of failure of the operational unit, which is online, the hot standby unit is activated automatically within 15 to 20 seconds. It may be less than that, but we have mentioned here 15 to 20 seconds. This time will depend on the machine configurations. How much RAM it is there, how much process speed is there on that. If we have a 3 LAN card, then we can use another LAN card for our wide area connections. One thing I will clear here for the Goa peoples, there is a range of IPs already allocated by the headquarters for the Goa, and we will use that IP range for server machine, for workstation machine, for anything. So whatever we are telling right now, local area network, actually Goa machine will be always on the wide area network, not in local area network. Single IP can be maintained for all the machines. In general, all remote station and other system like IPMSS, AMHS, automation, SMGCS, DATIS, SCDMX, etc. are connected over the Goa probably will be connected with the Bombay and with some RW stations. Direct wide area network, and that RW station will be connected over the wide area network. But as I told you, since you will be only on wide area network, so you will be connected on the same network only. So right now we know that two machine with the two hard disks and 2 to 3 LAN card and connection between the machine over the different LAN, ETS 0, ETS 1 or ETS 2, whatever may be, depending on the station configuration. These machines are COT products and ready to work on the Linux platform. I know that Goa is having the Dell machine, a desktop PC, and we have checked that desktop PC is ready to work on the Linux platform. And in generally, all this machine is having 2 number of NIC card. If possible, the third NIC card will be inserted on this machine for more flexibility of the operation. In case of failure of the NIC or non-availability of the spare NIC, single NIC may be used to serve all network within the wide area network. So there will be no issue if the some network card fail. You can use the single network card for the all work. Only you have to make some minor changes in the software. Software means application software. Now this network of the two machine, which is working as a server, will be connected with the supervisor terminal, booking terminals, then briefing terminals, like that. With a lot of terminals as per your station requirement. And all this local terminal will be desktop PC, workstation or laptop machine. And Microsoft Windows 10 Pro is by default preloaded operating system on the desktop machine. So you can use that Microsoft Windows 10 Pro. If you have any machines with the previous version Windows XP, that machine can be also used for front-end applications. You just see here is a line is written: user terminals and database server are in the same workgroup under the LAN. What is the meaning of this thing? As I told you that Goa will be on the same LAN. That means it will be on the wide area network LAN. Suppose your router's IP is 172.24.4. something. So your machines, your terminals, everybody will carry the same network ID for the IP. Why? Here it is written that database server also will be in the same IP, because Goa is not having any database server. Database server will be at Bombay and you will access that thing. Suppose in the supervisor position, sitting at supervisor, you want to find or make some query on the flight plan. Unless otherwise you are on the same network with the Bombay, you cannot access the Bombay database. That's why you are always in the wide area network. And that IP will be used, which IP? That is already allocated by the headquarters. Front-end application is terminal specific. What do you want to say by terminal specific? Suppose if you are using for a supervisor purpose, you will use supervisor application. If it is CNS, AFTN message booking terminal, then you can use the booking application. Suppose you are giving some booking facility with the other facility at the tower, it will be ATS application. Suppose at Goa some airlines ask for a terminal, then it will be remote briefing terminal application. If it is a remote station asking for a link, It will be remote AFTN terminal application like that. Different application is having different scope of work, and it is customized as per the requirement of that particular specific terminal. If Goa is having any automation, SMGCS or SCDM or AOCC facility, that also can be connected directly in the same network. And whatever the case it may be, all will be connected through Ethernet as a client node only. What I want to mean that whenever that you are working on the IPMSs and going to connect any system, other system, not supervisor, booking, briefing, NOTAM, etc. Say automation, SCDM, or say other IPMSs over the direct IP processing, always your system will work as a server mode and rest will be on the client mode. In IP-based communication, there is always two provision. Either you will be on the server mode or master mode, and other will be on the client mode, so that IP communication can be established. Normally, automation, SCDM, AOCC, all these things support ITA2 format, and SMGCS support IFI format. Before connecting any system with the mini IPMSs, you have to ensure that system is supporting ITA2 or IFI. Accordingly, you have to make the connectivity, and you have to design your line data, etc. accordingly. That's all about the main server portion, how it is connected, how the network is established. I'm not going to ask any question right now, just simply listen it. Later on, if you have any question, you can go ahead. Now, code system dual architecture. We will concentrate only on the two machines, that is server 1 and server 2, how it will work. Now, we have a two machine, say server 1 and server 2, and as I told earlier, we have a unique IP concept which is known as a virtual IP also. How that will be defined, let us just explain. Say now we have a two machine, server 1 and server 2, and both this machine is having its own IP. For server 1, IP is .1 and server 2 IP is .3. Okay, there is a two IP. Now I have another IP, virtual IP, say it is .5. This virtual IP physically doesn't exist. It is only exist that time when your any machine become online. That means now server 1 is online. That time you will see that one IP is generated automatically 172.20.1.5 on your particular that online machine. Now that online machine is having two IP, one is .1, another is .5. In case this machine get crashed, immediately that virtual IP .5 will be vanished from your network. That will not be available. Immediately after the crashing, that server 1 is having only one IP .1. But as per the normal procedure, once server 1 get crashed, server 2 will take over the charge. Whenever server 2 will take over the charge, server 2 will gain another IP with .5, which is your virtual IP. I think you got my point. Virtual IP is the IP which is not existing anywhere physically. But whenever one system is online, that system generates this IP for that machine. And if the system gets crashed, that IP will be vanished. If another system take over the charge, that system also will generate the same IP .5. If none of the system is working on the online, there will be no question of virtual IP. What is the benefit of this virtual IP? That means suppose I have a two machine. one machine is having IP.1, another machine is having IP.3. Now these two machines, this network is connected to another station. Say, for example, take it Bombay, connected with the Bombay. Now Bombay will start communicating with the Goa MSS, but Bombay doesn't know which server of the Goa MSS is online. It may be right now server 1, after 10 minutes or 15 minutes it may be server 2. If we are maintaining the 2 IP, then suppose Bombay has established the link with your server 1 with a physical IP.1, then if Goa changeover from 1 to 2 machine, that time your connectivity with Bombay will be stopped, is it not? Because now your machine IP is 0.3. But if we advise Bombay to connect Goa not with the .1 or .3, but instead of that on the virtual IP 172.20.1.5, then Bombay will not at all come to know which server is online. Whenever any system is online, it will continue working on that. I'll just take a break for just 1 to 2 minutes. That's all. Hello. হ্যাঁ হ্যাঁ এখন ফোন তো স্যার